Alright, welcome back, Algebra 2. For example 3, it says the intensity L sub t of light transmitted through ordinary glass of thickness t in centimeters is modeled by the exponential equation L sub t equals L naught of 10 to the negative 0.0022 t power, where L naught is the intensity before entering the glass. About how thick must the glass be to block out 10% of the light? Okay, so we want to think of this in terms of not how much we're blocking out, but how much we're actually letting in. So if 100% of the light, if we had no glass, we want to block out 10% of the light. How much are we letting in? Well, we take off that 10% that we're blocking out, and we're letting in 90% of the light. Okay, now again, we want to write this as a decimal, so we take this 2 places to the left, so we have 0.90. And this is going to be a little bit confusing for a second here. This is going to be times the original intensity. So we have 0.9 times L sub naught, and that's going to be the intensity that actually makes it through the glass. Okay, so 90% of the light's going to make it through, and that stands for L sub t. So that's the light actually that's going through our glass. Okay, so 90% of our original light is being let into our glass. If you're in physics class, this should make sense to you. All right, so 90% of our original light goes through our glass. All right, so we're going to substitute L sub t with 0.9 L sub O. And it's weird to plug in another variable for a variable, but that's something we just have to do here. So L sub t is going to become 0.9 L sub O, so 0.9 L naught, equals, and then the rest of this is actually just kind of going to be the same. So L naught of 10 to the negative 0.0022 t power, which actually works out in our favor. Since these are both being multiplied, we can divide each side by L naught and actually get rid of it, because we don't care what the original light was. We care what the thickness of our glass is right here, t. So we can get rid of our L naught on both sides. So then we're left with 0.9 equals 10 to the negative 0.0022 t power. And we're going to take the log of each side, and we can just use common logs or natural logs here. I don't see e, so I'm just going to use common log. So log on both sides. And when I do that, then I could go ahead and rewrite them here. So we have log of 0.9 equals log. Now on this one, it's a common log, so I know it's base 10 of 10 to the negative 0.0022 t power. Notice my base and my what I'm taking the log of here match, so this is that property where I can get rid of all of this and say we just have this negative 0.0022 t power. Okay, but it's not a power anymore. We drop it down into the log spot. So log of 0.9 equals all of that. Okay, if you need to rewatch some of this, please do, because I hope you're all on the same page here. And not much room for it, but I am going to divide each side by 0.0022 to get t by itself. So divided by negative 0.0022, and I get whatever t is going to equal here, because these will cancel and leaving me with just t. So now I need to do log of 0.09 or 0.9 divided by that stuff. So let's go ahead and grab our calculators here. So log of 0.9, close those parentheses, divided by negative 0.0022, and that should give me what the thickness of my glass is here. So t equals approximately 20 point, if I wanted to round to the second here, that would bump it up, so it'd actually be 20.80. Okay, get rid of that. Centimeters here. And that would be the thickness of my glass. Kind of thick if you think about it, but we're trying to block out 10% of our light, but and that's actually kind of a lot. If you need to rewatch that example, please do, because it was a little bit confusing. We'll be doing more work like that tomorrow. Next thing, we need to talk about our change of base property. Up until now, all we've been able to evaluate in our calculators are log of base 10 or our natural logs. So this change of base property actually takes care of when I don't have a log of anything else. Okay, if I have log of 7, log base 2, etc., etc. So it says for all positive real numbers a, b, and t, with b not being 1 and t not being 1, if I have log base b to the b of a equals log base t of a over log base t of b. And these t's, you can design this as such to be base 10. They just have to be the same number. So since we can put base 10s in our calculator, it would make the most sense to use base 10s there. So for example, let's just give you a for instance here. So log, let's say base 3 of 5. Okay, we cannot currently evaluate that on our calculator, but by using our change of base property, we could say, oh, let's just do log base 10 of, let's see what goes on top. A goes on top, so that would be the 5 spot here. So 5 over log base 10 of 3. So then I'd be able to actually figure out what this was by grabbing this guy and doing log. And now this is implied that it's base 10, so log of 5 divided by log of 3, both log base 10s, and we would get, well, I guess these should be squiggly signs, 1.46 for our log base 3 of 5. So log base 3 of 5. By using our change of base property, we don't really care about this stuff in here. It just helped us get to the 1.46 that we needed. Okay, so if you never can find a way around evaluating a log of a different base, now we know that we can use this change of base property. So this guy's pretty important, so I would make sure that you know this one. Okay, let's see where we would actually use this. So it says approximate log base 7 of 25 to the nearest thousandth. Now we cannot do this one in our calculators yet, so we use our change of base property to say log, and it's base 10, but I don't need to write it, so let's just say log of 25 over log of 7. And now that I can actually evaluate both of those because they're both base 10s, let's grab this guy. So log of 25 divided by log of 7. Well, bam. So that is approximately equal to 1.65, and they want to this thousandth, so we go out one more, so 4. Okay, so I wouldn't leave all your work like this. To write your answer, I'd say log base 7 of 25 is approximately equal to 1.654. And there you have it. That's how you use the change of base property. Pretty darn easy. If you wanted to, you can go ahead and always go back and check, because if we wrote this in exponential form, or this rather in exponential form, we'd have 7 to the 1.654 power. Does that equal to about 25? We can always go check this. So 7 to the, there we go. I'm actually going to put the rounded answer in there, 1.654, so that you can see what happens. It's about 25. There you go. It's 24.99. That's pretty darn close. So we would say yes, it checks. So we know that we used our change of base property properly. So that's all we have for today. Hopefully you got something from that, and we will work on your very last worksheets for this unit tomorrow. I know it's been a long one, but it'll pay off when you guys take your test here soon.